Okay guys, so we're going to have a look today at the Year 11 molds test. This is not the assessed homework, it's the test. So you probably, in fact you definitely should have the copy of your own test, possibly printed out if possible, or at least on another screen, or split this screen, either way. And the most important thing here is you fix your corrections and you have a look at where you went wrong and ensure that whatever issues you had, you can sort them out. Okay, and if you came up with a similar question soon, you'll be able to do it. Right, let's get this going. We have I2, so we have to calculate the relative formula mass of I2. So the atomic mass of I2 is 127, and we have to multiply that by 2, of course. We got 54 there. Okay, we did the same for K2O. So there's K2O, there's 2 potassiums, which are 39. So there's 2 of those. So it's, 2 times 39 plus the 16 gives us an answer of 94 in there. Then we have ammonium nitrate, so we have a nitrogen at 14. We have 4 hydrogens, okay, each of which are 1, so it's 4 in total. We have another nitrogen in there, and we have 3 oxygens, which are 16 each. So that gives me in total 48 for the oxygens, okay. So it gives me a total of 80. This one here a little bit more difficult because we brought in the 2 here, which multiplies everything in the brackets by the 2. So we have 2 nitrogens and 8 hydrogens. Okay, and all of that adds up to 132. Down here then, a bit more complicated, not too bad. We've got 2 potassiums, which are both 39, so we have 39 times 2. We have chromium, which is 52. We have 2 of those. And we have our oxygens there, which we have each are 16, and we have of course got 7 of those. Okay, so and that gives me, if I punch everything correctly into my calculator, total of 294. So there you go. That should have been a pretty nice little introduction to this test. Okay, so we'll just move on down. Okay, so this time, and this is important guys, that you read these questions carefully. You are operating this time to the nearest whole number you will see. Okay, so please make sure that you read these. What is the percentage of the following elements in the compound? So we're asked for potassium here. So we have 1 potassium atom. It's 39. So we do the number of atoms multiplied by the atomic mass of the atom over the total thing, which is the RFM in other words, which is 39 plus bromine, is 80. So we have 39 divided by the RFM, okay, times 100 gives us 32.78. That says to the nearest whole number, so obviously your answer should have come in at 33. Okay. Right, we're looking for chlorine and magnesium chloride. So there's 2 chlorines in it, so it's 2 times 35.5 is the top line. On top of the RFM, which is 71, that's the 235.5s. Plus 24, sorry. So that makes that 95. So 71 divided by 95, going to be a high percentage. So it works out at 74.7, nearest whole number, 75. Okay, nitrogen. So we had our nitrogens here. Now remember we had 3 of them. So our top line should read 3 times 14 for our 3 nitrogens. Over we have 18 times 3 plus 31 plus 64, yeah. So the bottom line would be 149. And we would get 28.18%. So we would record that at 28%. It says, again, the nearest whole number. Okay, so let's get rid of that. Okay, so what mass in grams then of the following? Okay, so we're going to our mass in grams. Of course, you'll be sick listening or looking at this. Is that. So what is the mass in grams? Do not include units. Again, read that. So we have N2 is 14 times 2, so that's 28 obviously, multiplied by 0.75. So our answer to that is a nice simple 21 grams. Here we have K2SO4, so we've 0.3 moles of it, multiplied by, we have 2 potassiums in there. Okay, we have sulfur, which is 32, and we have 64 because we've got 4 oxygens in there, which are 4 times 16. Okay, which is obviously 64. Okay, and we got 0.3 times that gives me 52. 52. Where am I? 52.2, which the nearest whole number is, of course, 52. In fact, no, it doesn't ask you for this question to the nearest whole number. This is a separate question. Sorry. Okay, we have our potassium chromate here, so we have 239, so 39 times 2. We have 2 chromiums, which is 52 times 2 is 104, and we have again 4 oxygens, 64. So RFM is 246, so 246 multiplied by, okay, gives me 1599, and that is grams, but of course it does ask you not to put units on there. Okay, so let's have a look. This question then was manipulating the previous equation, and now we're being asked this time to calculate how many moles are in the following. Okay, so again, moles equals mass. Can't do it. Mass divided by RFM. So we have got some boron, which is 11, plus our 35.5 times 3. Okay, for our 3 chlorine, sorry, that gives me 117.5. Okay, the mass of it that we've got is 58.75. So 58.75 divided by, that's going to be a half, isn't it? Yeah. So that is 0.5 is your answer there. Okay, here chromium is 52. We have 3 sulfurs, which is plus 32 for one of our sulfurs times 3, and we have 4 times 3. Okay, so plus 12 of our oxygens, each of which are 16. So 52 plus 32 times 3 plus 16 times 12, a big number here, so that's 340. So 425 divided by 340 is 1.25 moles would be your answer. Okay. Okay. So use the following equation to answer. So we've got an equation here. First thing I would do when I look at this is go 1 to 4 to 1 to 4. That's my ratio. So in the reaction, above 4 grams of sodium was reacted with excess titanium chloride. How many grams of sodium have reacted? Okay. Well, that's as easy a question as ever you'll get. So if it's 4 grams of sodium reacted with excess titanium chloride, well then all 4 grams of it are going to react. How many moles of titanium chloride will react with 4 grams of sodium? Well, we need to get our moles, so just remind ourselves mass equals moles times molecular mass, or RFM. So we have 4 grams of sodium. Okay, so that's 4 divided by 23 gives me 0.1739 moles of sodium. The ratio is 4 back to 1, so I need to divide that by 4, and that will give me moles of my titanium chloride. Okay, so that's 0.04. So that is that answer. What's the maximum mass of titanium metal that could be made from 4 grams of sodium? Well, if I have 4 grams of sodium, I have that number of moles of sodium, 0.1739. Okay, the maximum mass of titanium metal, so sodium to titanium metal is 4 back to 1. So therefore the moles of that I will get will be that value divided by 4, which is that. Okay, the atomic mass of titanium metal is 48, so mass equals moles multiplied by atomic mass, so that gives me 2 grams. Okay, so the answer to that one is a nice little round 2 grams. Okay, so let's move on to the next one. Okay, use the following balance symbol equation. And again, boys, first thing I look for here is 1 to 5 to 3. That should be a wee arrow there. To 5. So a student wants to make 36 grams of water. How many moles of water is that? Well, that's very easy. 36 over the RFM of water is, which is 18. What mass of propane should they combust to form this amount of water? Okay, well that is 2 moles of it. So the water back to the propane is a 5 back to 1. So we're going to divide that by 5 to give us the moles. We'll divide that by 5, which is 0.4 moles, but we've got to multiply it by the RFM of that, which is 3 carbons plus 8 hydrogens is 44. So 44 times that 0.4 gives us answer A. Okay, next one, use the following equation to answer the question on the limiting reactants. So we're in the limiting now. Okay, so we've got, again, 4 grams. Always fill in the info you get. Was reacted with 2 grams of HCl, 2 grams of that. What mass of sodium chloride was? So we've got to work out which one of these is in excess. So the MR of this, is 40. The MR of this is 36.5. So let's get our moles sorted. So 4 divided by 40 gives me, of course, 0.1 moles of that. Can't believe I did that in the calculator. Divided by 36.5. 2 divided by the 36.5 gives me 0.05 moles of that. So they're in a 1-to-1 ratio. So this is excess and this is my limiting reactant. So we're asked what mass of sodium chloride would I make, so it'll be determined by that number of moles. The ratio of HCl to sodium chloride is a 1-to-1 ratio, so you'll make the same number of moles as you have there. So mass equals moles times the RFM. The RFM of sodium chloride is 58.5. Okay, gives me 3.2 grams. Okay, there's your answer. Okay, next one, nasty. First thing you'll see here is you've got a very nasty set of reaction ratios here, guys. So just made this question a little bit more difficult, of course. Right, so in the reaction we have 350 grams of iron was reacted. So let's just fill in our info as we go along with 300 grams of aluminium oxide. Okay. How many moles of iron have reacted? Okay, so let's see, we've got 350 divided by 56 gives me 6.25 moles of iron. Okay, so 6.25 moles of iron is what I have. Let's look at my aluminium oxide. So I have 300 moles of aluminium oxide. Sorry, 300 grams of aluminium oxide. And I need to divide that by 54. And my 3 oxygens are 48. So that gives me my moles of this is 2.94. Okay, which of the 2 reactants is the limiting reactant? Okay, so we have a nasty ratio to deal with here. We have a 4 to 9, so I need to take my 6.25 and I divide it by 9 and I multiply it by 4. Tells me I would need 2.77 moles of aluminium oxide to react with this number of moles of iron. I've got 2.94 moles of aluminium oxide, so my aluminium oxide is actually just about in excess. Okay, so it asks you which one is limiting. So the iron is limiting if the aluminium oxide is in excess. What mass of aluminium can be made in the reaction? Okay, so if my limiting reactant is my iron, okay, that's my limiting. We're looking at aluminium. The ratio of that is 9 back to 8. So let's take my 6.25 divided by 9 and multiply it by 8. Okay, tells me, and we're after the mass of aluminium. Okay, so that gives me 5.56 moles of aluminium, and I need to multiply that by 27. Gives me a nice round 150 grams of aluminium that would be produced there. Okay, next question. Right, so we are using this equation. Well, that's a nice one, nice 1-to-1. Okay, so in a reaction between zinc and copper sulfate, 6.5 grams, or sorry, scandium, I should say scandium, not zinc. Okay, scandium and copper sulfate. Scandium was added to excess copper sulfate, and 1.28 grams of copper was formed. What's the percentage yield? Okay, so let's say our scandium. So we started off with 6.5 grams, or 6.5 grams, yes, over the atomic mass of scandium, which is 45. Okay. So we started off with 0.144 moles of the scandium. Now if we go from scandium to copper, that's a 1-to-1 ratio, so I should make the same number of moles of copper, and the atomic mass of copper is 64, so I should take mass times RFM. I should make 9, I should make I'll go up here. Okay, 9.24 grams is what I should make. I only made 1.28 grams. Okay, so I do my actual mass for my percentage yield over what I should have got, called my theoretical mass, and then of course I times that by 100, and my answer works out there at 14%. Okay, so let's move on. So in this reaction here, rather nasty looking one, so I made this a little bit more of a challenge for you. So in this reaction, we took 5 grams of ethane diamide, okay, which is this compound here, okay. And we had, let's see, start this again. Okay, so alright, so we have 5 grams of our ethane diamide, so we'll do 5 over the RFM of the ethane diamide, which is change that. That should be a nitrogen there, and that should be a nitrogen there. Okay, so ethane diamide, we have 16 plus 14 plus 14 plus 16. So the RFM of that is 60. So our moles is going to be 5 over 60, which gives us 0.0833 moles of the ethane diamide. Okay, it was reacted with 20 grams. So the ethanol chloride is here. Okay, so we will see we have 20 grams of the ethanol dichloride. Okay, so we'll take our 20 and we'll divide that by our RFM of that, which is 78.5. Okay, it gives me 0.25. Now the ratio here is 1 here going over to 2, so we need to take this value to work out what's in excess and multiply it by 2, so 0.0833 times 2 would mean we need 0.167 moles of that, but we have way more than that, so this is in excess. So my ethanol dichloride there is in excess, so this is my my limiting reactant, if you like. So how many moles of ethane diamide would be made? Well, that's your ethane diamide here, okay, and this that one there. Okay, that I'm trying to highlight at the minute. It won't let me do it for some reason. So let's see if it will let me. No, it's decided not to let me do it. Okay, that's fine. So we have the one, if we have here, we have a 1-to-1 ratio, okay, of ethanol diamide to ethanoid chloride. So if that's my moles of ethanoid chloride, then that is also my moles of ethanol diamide. So we need to, yeah, so the answer will be the same then. Okay, it'll be the same. All right, so it's A there. It won't let me highlight it for whatever reason. I don't know. Stop working, but it'll be A. Okay. Right. How many moles of ethanol, chloride, and ethanol diamine reacted? Well, ethanol chloride, the number of moles of it reacted would have been this, the 0.167, because we had an excess of it, so the 0.255 is the wrong answer there. Okay. It's just a 0.0833 times 2. So the answer is this one here, the 0.167. Okay, so 6 grams of our product was formed. What's the percentage yield? Okay, well, let's have a look at that. Our percentage yield is we would have expected to make 0.0833 moles of it. Okay, so we need to take the 0.0833 and multiply that by the RFM of our desired product, which is the ethanol diamine, which is the one that my cursor is hovering over now. Okay, so let's see, we have to get the RFM of that, so that is CH3, so that's 15 plus 12 plus our oxygen is 16. I'm just going through the formula here. Plus 14 plus 14 plus 14 plus 15. Okay, so that gives us definitely not the number I just got my calculator. 16 plus. So that's an RFM of 144 multiplied by 0.0833. Okay, so we're multiplying that by 144. Gives us, we should therefore have made a mass of 12 grams. Okay, that would have been my theoretical mass. My actual mass, if you go, sorry, we go back down to the question, was 6 grams. Okay, so our percentage yield calculation would be 6 over 12 times 100. Okay, times 100, sorry, which is of course 50. So your answer should have been, for the last question, should have been part B, this here, or the 50 grams. Okay guys, hopefully that helps you and you can see where you went wrong. Sorry that the pen wouldn't work certain times, but it's just technology, okay?